So what we figured out is a way of serializing closures, right? As developers, we know how to serialize data, that's just JSON. We know how to serialize code, that's just JavaScript. But what we gave you here is the ability to serialize closures.
I'm just going to say, ooh.
Yeah. It's just a very fundamentally different approach. And things that are hard in other approaches, like for example, loading a clock when it becomes visible, right?
Yeah.
Is like trivial in Qwik.
Hi, everybody. I'm Tony Alicea. Welcome to this very special episode of Don't Imitate, Understand. I am super excited to have today on the channel Miško Hevery, creator of AngularJS, creator of Angular, busy guy. And he's coming to us today to talk about a new framework, Qwik, Qwik. And I'm super excited about the direction that this framework is looking to take JavaScript frameworks and front-end development in general. So welcome, Miško.
Thanks for having me.
Yeah, awesome.
Oh, it's an honor to be here.
Yeah, I'm going full disclosure. I'm a fan. A lot of people on the channel, they know that the first online course I ever did was a course on AngularJS. That really got me into this world of technical education. I've been an Angular advocate elsewhere. So I am super excited to talk to you, but we're not here to talk about Angular. We're here to talk about Qwik. But first of all, just maybe you could tell us, a lot of people here watching the channel are familiar with Angular. So what have you been up to since the Angular days, and how did you come to Qwik?
Yeah, so I think the journey starts, in 2019 when I was on a stage of NGConf. I was giving a keynote and I was like, here's some crazy ideas of how I think the web applications should start up and work. And I was talking about this thing called Resumability, etc. And of course, I give this talk and nothing happens, right? Like, people always think like, oh, you give them the secret how something works and they'll steal it from you. But reality is like no, you gotta like work on it hard to get somebody to steal. Once they start stealing, the answer is obvious. Like that comes later. Anyway, so nothing happened after that talk. And in the back of my mind, I was like, I really want this. Like we could do so much better in the way web applications work. Anyways, about a year and a half ago, I started kind of thinking about this really seriously. And then about a year ago, I actually left Google and joined a startup. I always wanted to do a startup. Like startup was always in my kind of heart. I was like, I want to see how this thing works, etc. I want to influence them from the very beginning. And so I joined, and it's like actually a good marriage between what Builder does and what we do. Builder does a headless CMS system. We always say like, it solves the same thing as a headless CMS is, but it actually isn't the headless CMS system. It solves it in a very different way. And so there's a lot of different kinds of, which we believe to be a lot better trade-offs between how the developer experience is with the CMS system than most systems have. But anyways, we're not here to talk about that.
That's okay.
I can come back and we can talk about headless CMS.
Sure, absolutely.
But the thing I liked about it is it has a huge set of customers that are e-commerce customers, and that they really care about time to interactive, right? Like if you navigate to a Nike website, right, it really matters in terms of sales and, bounce rate and all that stuff. How long before, if you send a link to somebody with a shoe and, the person's on Twitter, whatever, he clicks on a link and they're like, oh yeah, this looks like a good shoe, let's buy it. They hit the buy button and nothing happens, right? It's annoying. And at some point you're like, forget it, I'm leaving. Like, I really don't need the shoe.
Yeah.
And so e-commerce is a special place, which is that startup performance really, really matters. I'm going to say startup performance matters everywhere, but it like really hits home for e-commerce. And so Builder has a lot of e-commerce customers. So it's kind of a good match between like my goals of like making the web faster, and specifically had a set of customers where like this matters to their bottom line. And so they're willing to do just about anything to get there.
Nice. So it feels like we're getting a little bit already into the goals of Qwik. It sounds like I heard time to interactivity, which really just means, okay, I've requested the page. How soon can I, the user, tell the page I want to do something? Essentially.
Yeah, that's exactly what it is. Like if you imagine like you navigate to example.com and there's a button on it And as soon as you see the button, you click on the button, right?
Yeah.
And so there's two questions that you really want to answer, which is how long before I see the button? And that pretty much is all governed by the server side rendering caches, etc. Like in terms of frameworks, especially if you have a pre-cached content, you have very little control over that, right? Like it's just a CDN delivery thing that delivers the HTML.
Mm-hmm.
And we're pretty good at it as an industry. Like we can deliver the button pretty quickly for you, right? And the second thing is once I see the button, I immediately click on it. How long before something happens? Like let's say it's an add to the shopping cart button. How long before the item actually is added to the shopping cart? And actually, there are two problems. One is that if you click on it too early, your event is just going to be thrown away, right? So that's a problem. So you might click on it multiple times and nothing's happening, like because the event got thrown away or because like the system's not ready yet. And then finally, when you do click on it, there's a huge delay before the application downloads and executes and reconciles and hydrates, etc. And so that's the second thing. And when I say huge, like on a mobile network, Google simulates this with something called Google PageSpeed, right? And in the mobile network, it can be as bad as 30 seconds, like crazy stuff.
Yeah.
Right. And so this is the thing that we're after. And of course, people always say like, well, my app's plenty of fast. I'm like, yeah, on your desktop on a local network.
Right.
Like,
yeah, reality is a different story.
So reality is a different story.
That's really interesting to me because on the user experience side of things, which is another area that I have worked in, is there's this whole mental model thing about non-developers. So somebody comes to a site and they click on a button. Our mental model is, oh, it's downloading the JavaScript. But the mental model of the average person is, this thing is broken and does not work, right?
Yeah.
So it affects trust. It affects whether somebody's even going to bother coming back and trying again because their assumption is, this thing doesn't work. I clicked it 3 times and nothing happened. And then on the speed side, I think that's such a huge issue because there are so many developers who assume the world has 5G with the new iPhone.
Yep.
And that's just not true. So much of the world is on 3G networks, on 2, 3, 4, 5-year-old cellular phones. They're on prepaid plans for internet with limits, right? So you're asking them to download this big bundle is actually taking away from the money that they set aside for that month for their internet. And I feel like there are companies out there today who are essentially coding themselves out of a market, by essentially saying, well, we can't go to that site because my phone battery dies and my internet goes every time I go there. So it's very interesting to me, the idea, even just for companies to say, we want people to know that our site works and we want as big a market as possible. That seems like a win for everybody.
It is, but it's super hard to get there. Like, this is the thing that I'm kind of struggling with, is that you go to like Google PageSpeed or you go to any website that is slow, and then you say, okay, the website is slow, and we as a community are like, well, that's because those developers are not very good and they made a mess. It's like, not really, because like the problem is all websites are slow, right? Like if you had a world where like some websites would be fast and some websites would be slow, then you can be like, yeah, clearly some developers just don't know what they're doing, right? But if you live in a world where like every single website has way too much JavaScript, maybe like as an industry, our approach is wrong.
Yeah.
And that's kind of what I'm getting on with Qwik, right? Qwik is kind of the fundamental rethink from ground up of like, how exactly are we building sites? How do we make them interactive? And how do we make it in a like least expensive way? And that's kind of it's a big thing, right? And anyways, maybe I can show you some demos and we can kind of go from there.
Let's do it.
So let's talk about our homepage. And on the left and the right are basically our two identical sites. One is kind of built using the existing set of technologies. And it's the other one on the right-hand side is built using Qwik. And so I'm going to hit play. And this is how long it takes for the pages to show up. And then what you see is that the page stays colored for a while. And that's the JavaScript running. And eventually the page goes gray. Gray means that the JavaScript's finished, and now the page is ready for interaction. So let me show this again. And what you see is that with Qwik, the HTML shows up faster, and then there's essentially no JavaScript, and so it immediately goes to gray. Whereas with existing technologies, the hydration, the cost of kind of booting up the application can take a lot of time. And so it's a huge difference in performance that you see over here. And so what we're after with Qwik is basically solving that problem, right? Making sure that the pages start up fast.
Gotcha. And that's fast. And so you just said you're not loading any JavaScript, which is super interesting. I'm sure we'll talk more about that.
Yeah, we'll talk about that. Yeah.
But the idea,
and this is simulating, like mobile 3G network, etc.
Right. Gotcha. Okay. So you have this super fast load. You're not loading any JavaScript initially. And this idea of saying, okay, speed is going to come from less JavaScript, essentially. And then you also said hydration, which for our watchers, by hydration, we really mean, okay, you've loaded the HTML. Essentially, now you have to hook up the callbacks for all the events, more or less, right?
Yep.
And so I have a button, but when the click event fires, I don't necessarily have a callback registered. And so now we have to go through and figure out, now make the app, now that we have the DOM, now make the app interactive. Is that right?
Yeah, so you're basically describing hydration. And I actually want to take a little side note here. And a lot of frameworks basically claim speed. And I think it's important to really talk about, like, there's different kinds of speed, right? And so when usually you look at frameworks and claiming how fast they are, what they're talking about is once the application is up and running, how fast can they like add 1,000 rows, or remove the rows, or like change something in the screen or whatever, right? So what they're really talking about is, like, once the app is running in your browser, what is the performance? And my take on it is, like, first of all, it's important, but I think it's kind of secondary, because no matter which framework you choose, usually the issue isn't how fast the application runs once it's up and running. The issue is how long it takes for the application to get going, right?
Yeah.
And so when people focus too much on runtime performance, I think it's missing the point. And I'm not saying it's not important. It's just that the thing that we're talking about here is a really different kind of performance. We're talking about a startup performance of the application, which is exactly as you pointed out. Like, if you're on a mobile 3G network and you're paying for every byte of the internet that you have, like, you really don't want to necessarily send stuff across. And the way the current technologies work is that they send everything actually twice. They send it once as HTML, and then again as JavaScript that goes and re-renders everything. And hopefully when they kind of do the switcheroo between the static page and the dynamic page, you won't see anything because they rendered the same exact thing.
Gotcha. And then on top of that, I suppose there's also the framework itself, right? Whatever framework you're running is also being loaded initially so that you can build your application.
Yeah. I think in practice, the size of the framework is not a big deal.
Okay.
Like, frameworks are usually somewhere between 15 and 50 kilobytes, somewhere in that range. But usually sites are in like multiple hundred kilobytes,
right,
to maybe megabyte range. And so, like, yeah, the framework size matters, but not that much. Qwik is on a smaller side, but like, I just don't think that's really the thing that you should be focusing on. Not, in practice, it's not the thing that actually matters. And, there's a lot of people who make, like, look at how tiny my Hello World app is. And again, I'm going to be like, yes, but like, in practice does not matter, right? It's the big apps that really matter. Like, how do I build an Amazon kind of like UI that I can access on a 3G mobile network, right? That's the thing I'm interested in. Not like, how do I build a Hello World and look how tiny it is.
Yeah. So your graph of your like bundle size and, I suppose, relative speed to interactivity is kind of linear to the amount of code you're writing in most of these applications.
Yeah. And in the case of a Qwik, it's fixed. Like, the startup cost is fixed no matter the size of your application. And that's kind of the different or the weird thing about Qwik that takes a long time for people to get their head around, right? Because they just assume that, like, oh, the bigger site takes longer to load. And the thing that Qwik is trying to aim for is, no matter the complexity of your website, the startup performance is always the same.
Interesting.
Anyways, maybe you could do some demos, and then as we go through the demos, it will become more obvious as to what's going on.
This is exciting. Let's do this.
All right. And ask questions.
Okay.
So you got to start with hello world, right? This is on a hello world page. And the thing I'm going to show you here is, first of all, a bunch of code shows up. And of course, we have our HTML that, everybody has to send over. So it's a server-side pre-rendered thing. What I'm going to do is I'm going to kind of filter this down. And I'm going to say, actually, I'm only interested in JavaScript. And I'm going to get 2 pieces of JavaScript here. This is actually Vite. As you can see over here, this is Vite. Vite is the thing we use for development so that we can have hot module reloading and things. In production, Vite is not actually being present.
Okay.
So what I'm going to do is I'm going to filter out Vite.
Gotcha.
And I'm going to say, don't show me Vite. And so now what you end up here is you actually end up with no JavaScript, right? There's no JavaScript actually sent. And well, that's not that exciting. I mean, the page is static, right? There's nothing you can do to click and interact. And so the fact that like no JavaScript showed up on this particular page, like that is not that interesting. I mean, any framework basically can do this by just not sending JavaScript.
Yeah.
I think what's unique about Qwik is that Qwik figured this out on its own. You didn't have to do anything to tell the framework that this is the case. It basically just kind of looked at your code and be like, actually, you don't need any JavaScript over here. I'm not even going to bother sending it. Not only that, like there's nothing you could do on this page to kind of force the page to reload, right? Or rather, the page to cause any interactivity. The only thing to really kind of show at this particular point is that this is very React-esque. And this is kind of intentional. This is not a coincidence. And so you declare your component, and you just put your JSX in here, and that's it. Like this is how you kind of create components. So the thing to kind of point out is that a lot of times people come to Qwik and they see, oh, it looks just like React, and so they're like, well, why do I need something that looks just like React? And then they leave, not understanding that the real magic behind Qwik isn't about the developer experience, although we think we have a good one. The real magic is actually what happens on the back end. Right. And that's the thing I want to kind of show you and kind of demo.
Okay, great.
Okay. So let's do a counterexample. There are 2 buttons here. You can click hello. And when you click hello, a console log prints the hello. And when you hit click, it increments the count. Right. So that in itself is not that exciting. But let me show you what happens again. So let's refresh this. And again, we're going to show you no JavaScript until I click hello. And when I click hello, only the piece of code that contains the console log hello shows up, nothing else. And of course, it prints hello, and you're done. So like, why is that exciting? Well, it's exciting because of how you implement this. So you go to the counter, and here's your standard counter, right? So again, we have a component that's a counter. We say we have a state which starts at 10. We data bind the state into the UI, and then we have 2 buttons here. One does hello, and the other one does increments the count. And the thing to notice here is that we wrote the application in a single file, the way we would normally build stuff in the UI, right? And yet, even though we did it in a kind of a standard way, the system was able to kind of break it apart, right? The system was able to take this function right here and extract it out and say, actually, the only thing that you actually need when you click on that button is that log over there and nothing else.
Interesting.
Right? So instead of downloading the whole application,
right,
the system was able to like look at it and it's like, yeah, the only thing you need is that button over there, nothing else, right? And that's exactly what happened. When I clicked on hello, just the console log downloaded, right? This thing is not even like, it had to be extracted out of here, right? Like it's not even, it's not like you wrote it as a exported thing. Like the system was smart enough to kind of go in and be like, oh,
right,
let me extract this thing and pull it out. So what actually happens is that every time you see this $ here, this is, you should think to yourself like, oh, this is a lazy loaded boundary. This is where lazy loading happens, right? And so because this click has a $ here, what happens is this piece of code here gets extracted to something like export const foo equals something like this, right? And then the system can lazy load this particular part.
Yeah. So this is like extreme lazy loading, but it's almost like imperative versus declarative lazy loading? Because I, the developer, don't have to say, please lazy load this.
Yes.
It's the act of saying, because I need this JavaScript on an event, I already know that I can lazy load it on the event.
That's right.
Okay.
So it is extreme fine, like it is as fine-grained as you could possibly imagine, right? Like you cannot go any simpler than this.
Super
And
interesting.
so,
Yeah, sorry, keep going. Sorry.
no, so the question would be like, well, how does this work, right?
Yes.
Like let's dive into it. So let's click on the hello button here. And what we're going to see is that this button has an on-click property.
Mm-hmm.
And this on-click property has a URL to what needs to be downloaded and also the symbol that's exported inside of this URL.
Okay.
And so what we have here is information that the system needs to lazy load and then execute, right? So this is the part to lazy load, and this is the part to execute inside of that lazy loaded chunk.
Gotcha.
And so the question is like, well, how do you, like, normally browsers don't know how to do this, right? And so there's this thing called Qwik loader. And a Qwik loader is you can think of it as a polyfill. Right now we're running in a dev mode, and so it's pretty printed. But this Qwik loader is, when minified, it's about 1 kilobyte.
Not bad. Mm-hmm.
And it is so small that we actually just inline it directly into the HTML
Save
response.
a round trip that way. That makes sense.
We save a round trip, right? Because it's a kilobyte, and then the overhead of a fetch is like probably a kilobyte anyways.
Your HTTP header might be bigger than your code. So
that's right. So it's better to just inline this particular thing.
Yeah.
And the thing about this Qwik loader is that we don't expect this Qwik loader to get bigger. Like it's fixed. No matter the complexity of your application, the Qwik loader always is the same size. As a matter of fact, the Qwik loader has nothing to do with your application. We almost think about it as a polyfill.
Mm-hmm.
And a polyfill is that Qwik loader basically knows how to read these attributes. That's all it is.
Gotcha.
So Qwik loader sets up a global listener for a click event. When you click on this button, the click event bubbles up, right? Mm-hmm. It's intercepted by the Qwik loader. And then the Qwik loader, reads the attribute, and based on that attribute, it knows what to execute.
Oh, that's interesting. So right from the start, you're already saying, I'm not even going to add a bunch of click handlers all over the place. I'm going to add one click handler. No matter how many buttons you have on the screen, we're just going to look at the target that caused the event, and then we're going to look at these couple of standard HTML attributes. And then we're going to go from there, basically.
Yeah, that's like 80% of the story.
Okay.
The 20% of the story is like, well, how did we know to put that stuff there?
Right. Yes.
All right. And so that's a little more complicated, and it really comes down to this idea of resumability. And so let's go back in time. And I remember when I first saw a VMware, the virtual machines, I was kind of blown away. And specifically, I was blown away because I could boot up let's say I was running Windows, I would boot up Linux inside of my Windows machine. Like that in itself is like mind-blowing, but that's not the real thing that blew my mind. You could boot up Linux inside of it, right? Let's say you open up Linux, boots up, you log in, and then you open up a word processor and you start typing a letter. And then at some point, you save the virtual machine. You save it to a disk, right? Mm-hmm. And you take the file that you saved, and you can actually send it to your friend. And your friend opens up the file and resumes the machine. And the machine is exactly where you left off, right? You don't go through the boot up process. Right. You don't go through the opening up of the word processor. You don't go through typing the letter. You are just exactly where I left off, with the letter open and, ready to take on next character.
Yeah. And I remember my first time seeing that too. And I remember thinking, and I'll get like a little bit computer sciencey for a second. I remember thinking, well, a computer is a finite state machine, more or less. So it takes total sense. You should be able to just have the state and start up the state again and keep going in the state machine. And why don't we do this all the time?
Right. So that's exactly what's happening here, right? The application starts up on a server. It gets itself to a particular state. We snapshot the state. We send the state in the form of an HTML into the client, And on the client, we continue where we left off, right? Essentially, if you think about the reason why websites are slow to start is because websites have to boot up, right? The reason it's slow is because you're paying for the boot up, right? We call it hydration.
Right.
We have fancy names for it, but like fundamentally, the website is booting up. This is what's happening, right? And so the reason why Qwik applications are fast to start is because they skip the boot up. They literally just go like to the exact state that it was on a server and continue where you left off.
Okay, that's heady. That's a different mindset.
Yeah,
that's a very different mindset. It's not, hey, I figured it out on the server and now I'm going to send you the results, but it's basically a picture, right?
that's
And
right.
then now you have to do the work of figuring out, well, here's where the components are, and here's where and everything else, and now you're actually, it's almost like OCR, right? It's almost like, hey, we're going to now take this picture and make it into an actual thing. What you're saying is, well, what I'm sending you is the HTML along with enough information about the state of the application to continue, but it's not the entire state of the application, right?
It's actually the entire state. But yes, exactly that's what's happening. So the state of the application is actually stored in this file called Qwik.json right here.
Okay, gotcha. Ooh.
Okay. And right now in here, the only thing that matters is this count, right? Because this is the count 10.
Gotcha.
And we'll get into it in a second. I don't want to get ahead of myself. But yeah, basically the reason we have hydration, right? The reason why existing frameworks take too long to boot up is because they're missing sufficient amount of information and they have to recover that information. And the only way to recover that information is to rerun the application from the very, very beginning. And this rerunning is the expensive part, right? And this is the thing that we're skipping. The other thing to point out is that when you make that VM file, right, that you save to disk and you send to your friend, there is no rule that says you have to only send it to one friend. You can send it to 50 friends. And they all will open up the file and they will all start off where you started, right? So the intermediary value of the HTML is CDN cacheable.
Right. So basically you can, okay. So I'm getting, so two things are coming to mind. My first thought was, oh, you do have all this state, but in reality, you're saving so much by not having all the other stuff that, having the state there isn't really that big of a deal.
Correct.
And then resumability is really, I have it essentially a serializable application or a serializable application state, including the UI.
That's exactly it.
So when we say serializable for our watchers, we're essentially saying usually I can take this thing that's split up in memory locations in the computer and turn it into a string, and then pass that string around, and somebody else can take that string and recreate the same kind of memory structures in the computer, and now keep going on the computer. So,
that's exactly it.
So is that what you mean by resumable?
That's exactly what I mean by resumable, yes.
Wow. That's pretty cool. I have to process that.
Yeah. And so I, just kind of point out things that may not be obvious. Like other frameworks, for example, Next.js will serialize the state of the application into like a script tag in the same way. But the thing is, it's not just the state of the application that matters. You also have to serialize the state of the framework itself. People don't really think about the state of the framework because they're like, it's opaque to them. But that has to also be serialized, right? So like the state of the application is really 10, right? 10 is this count of 10. That's my state of the application because it's a trivial application. But it's not just the 10. Like I also have to serialize all of the locations of the listeners, right? And because Qwik is reactive, we'll get to it in a second. I also have to serialize the fact that if you modify the count, I need to invalidate component 0. I also have to serialize the fact that like if the component has to be rendered, where exactly do I get the rendering for this particular component? So there's a lot more information that the framework needs to keep about your application, right? And the way the frameworks retrieve this information is they re-execute your application, but that kind of defeats the whole purpose, right? The whole point, what's unique about Qwik is that Qwik knows how to serialize its own state, not just the state of the application, but also its own state about like the meta information about your application, right?
Yeah.
Such that it can just continue where it left off.
Okay, that's very interesting. And that's a great point. So when we're dealing with, if we're talking about machines, right, you have the server machine, and then you start the machine over under a lot of these frameworks. And so not only are you figuring out your state, you're figuring out the state of the machine to feed the state into and then keep going. So now you're saying, well, Qwik, we're just going to kind of copy the machine over. And
that's exactly right.
Yeah, that's super interesting.
That's where the power comes from.
Yeah. So
right? And this is
no, I was just going to ask, is it fair to say that in a way you're serializing into the DOM what may otherwise have been, the framework is trying to capture?
That's exactly what's happening. Yes.
Okay.
So the HTML, right? I mean, DOM is the non-serialized version of HTML, is the serialization, right?
Sure.
So HTML contains all of the information that a framework needs to reason about the application. Okay. So there's two things going on. First, like you have to save all this information. And there's a second thing that needs to happen, which is you need to break up your application into pieces, because if you don't know how to like make multiple chunks and you can only deliver the whole application in a single monolithic chunk, which is the problem with existing frameworks, then you're not actually solving anything, right? Because then the answer is like, well, I clicked something, great, but I have to download, 300 megabytes or whatever, 300 kilobytes or something of the application. It's too much, right? Like I need to be able to not just make sure I don't have to go to the boot up process, but I also need to delay the amount of JavaScript that's available for me, right? And so this is where this comes in, right? Like again, if I go to Network tab, I hit on the hello, and the system was able to just download the piece of code that's strictly necessary for this particular page and nothing else.
Yeah. So now, in a way, you're not serializing all future state. You're just serializing the state at the moment, and then you can load what you need for the next state.
We serialize the full state. We serialize the full state, but we take the application and break it up into pieces now.
Okay.
So here's a counter, and this counter is a single file, which is a single symbol that's exported out of the file, right? There's only one thing in here called counter.
Okay.
Now, what we need to do is we need to lazy load this bit over here. And I showed you how we do that by extracting this particular thing into a top level function. But this thing over here is a lot more complicated problem, because if I just extract it to a top level, like you see over here, this is the extracted version of this, right?
Right.
Notice what happens here. Right?
Yeah.
It's like, what is store? Like you pulled something out.
You've lost the scope.
You lost this. That's right. Lexical scope. You lost the lexical scope of this particular thing. So this is not something you can do. Instead, you have to do something slightly more complicated, and it looks like this, right? Where you say, at the end of the day, I just want to do count plus plus, but I need to restore the count.
Right.
And that's on the object called store. And so I have to generate this magical piece of code here called use lexical scope that knows how to restore the store. That's kind of a mouthful. So that you can increment the count.
Right. And it's probably some closure-based thing that you have to worry about, stale closures and other stuff.
Yeah. So let me show that, right? So here we clicked on hello, and I printed the hello world. Now when I click on the other button, the first thing that downloaded is the store count plus plus, right? This is that bit right here.
Yeah.
Right. But the store had to be restored, and so it had to insert this use lexical scope bit.
Yep.
Then we modified the count property. And so now the framework has to be smart enough to be like, oh, you modified the count. Now, in this case, we only have one component on a page. But in the reality, you would have lots and lots of components. And so framework has to be smart enough to say like, oh, you modified something that invalidates this specific component. And therefore, I need to download that specific component. So the next bit it downloads is actually the framework itself, and followed by the JSX for the component.
Gotcha.
Now, in this particular case, the component is the whole application. And so, no wins here, but when we go to a more complicated case, you'll see it. And so this is basically how the system knows how to put it back together, right? So there's two problems. One is you have to be able to serialize everything.
Mm-hmm.
Second problem is you have to be able to break things up into small chunks.
Yeah.
Because one of the problems you have with existing systems is that there is no easy way to break up your application into smaller chunks. And I know people will say, oh, but you can use lazy loaded boundaries, and we'll talk about it later, and I will explain to you why they're not as useful as you think they are. Like, it's one of those weird things where, when you have a large application, you think you can just lean on lazy loading, but it turns out not so simple. And this is why in practice, almost nobody does it. We'll talk about that later.
And just for clarity, this is interesting. So just for clarity, when you showed that code downloading that used lexical scope and all of that, that was Qwik figuring out how to do that based on just the simple component that you wrote.
That's right. So you as a developer wrote this, and you didn't have to think about anything, right? You just wrote this the way you would write it in any other framework. There's nothing here that really requires extra hoops from the point of view of the developer.
Interesting. That's, yeah. And let's be honest, developers as a culture are a culture of path of least resistance, right? For adoption.
Yeah. I mean, you have so many things to think about, like you don't have time to whatever, right? That's kind of the point I'm trying to make here with Qwik, is that you should have a system that the path of least resistance is the correct path.
Yes. Yes.
Yeah.
Make it easy to do the right thing and hard to do the wrong thing.
Exactly. And so the point here is that this is how you would write the code, right? This is because this is it. Like, we decided that this is the best DX. This is the DX you get, right? Everybody writes the code in this particular way. And yet the thing you get out of it is this totally fine-grained, lazy loading behavior.
That is really cool.
Okay.
I feel a little bit like, now I'm going to go way back. I feel like the first time I saw computed work in Knockout.js, like I'm going away. That was my first ever time seeing anything like that in a framework, right? So you're like, whoa, that's great. It just did it for me, and I don't have to think about it. This feels like that, but of course on a much huger level, where, hey, I incremented something that should cause a state update or should be affected by the component. I don't have to think about any of that. I'm just telling Qwik, this is what I'm changing, and Qwik's doing the rest. And again, that feels very declarative to me. So that's super interesting.
That's exactly what's happening. So before we actually leave this example, I show you something cooler. I want to just point out a couple of things here. See how there's a bracket 0 on the end here, but there isn't a bracket 0 here?
Yep.
So one of the things I want to show you is that this state of the system right here, when I click the button that increments here, that script tag disappears. Because when the application booted up, the framework consumed that state of the system, right? Because if we were to leave it behind, it would just kind of be lying, because it's not actually what, the state is not 11, etc.
Makes sense.
So that gets consumed. But if I refresh this again, so here's our state here, and then here is our button. Where's our button? Here's our button. And it has this 0 in here. This 0 is important because when I click on it and I go to the network tab, this is restoring the store, right? How is it supposed to know which store do you mean?
Oh, right. Right.
So that comes from this information here, right? So what's happening here is that you have 3 bits of information. You have, what chunk do I download? Out of that chunk, what symbol do I download, right? Because there could be more than one symbol inside of the chunk. And finally, what state needs to be restored in order to make that function run?
Right.
So what we figured out is a way of serializing closures, right? As developers, we know how to serialize data. That's just JSON. We know how to serialize code. That's just JavaScript. But what we gave you here is the ability to serialize closures.
Ooh, I'm just going to say, ooh.
Yeah. That is exactly ooh, right? So at its lowest level, what's happening here, and the reason why all of this stuff works, is because we figured out how to serialize closures, right? Because when you look at this closure right here, right, this closure closes over the store.
Yeah.
right? And if you want to lazy load this bit of code over here, and this is why lazy loading is so hard in the existing systems, is, well, it's not just about downloading the code lazily. That's easy.
Yeah.
It's about restoring the code's state, because code has amnesia, right? Like when you just download code, like it knows nothing. There's no state. And so it's about restoring the state of that function so the function can actually run.
That's great. So I'm just going to pause again. So when we're talking about closures, this is something we've talked about on the channel, but we're really talking about not just the function, but the function's environment, right? Because JavaScript functions are first-class citizens and can get passed around, and they get executed later. On later execution, they're also aware of any variables that they should have access to, as if they were executed them in that line where they were created, right? And so now you're taking these other variables outside the function that the function needs to have access to, and you are somehow saying, here's my function, and here's that outer environment of the function, and you can hand that to anyone, and then now you have the full state of the JavaScript application.
That's right.
Awesome.
And so to put it differently, like people know how to lazy load functions. They do not know how to lazy load closures.
Right.
Right. And I'm going to say, in order to make the application lazy loadable, what you really need is a way of lazy loading closures, not functions. And this is why it looks like at first sight that you can lazy load your application, but in practice, it turns out it's not possible.
Right. I mean, you would have to try to have everything be pure, but in full context, it doesn't always work out that way, right?
That's right. And specifically for the listeners, right? Because listeners are kind of the problem that kind of messes these things up.
Yeah.
And we kind of touched on it, but like the other thing that you have to understand is existing frameworks have this problem that they have a method where you kind of bootstrap, right? Like you say, this is my root component, and go and render that root component. And that root component then points to child components, and and the whole tree kind of comes with you, right?
Yeah.
There is no way to kind of like reach in the middle of that tree and be like, start over here. Like frameworks don't understand that. Every single framework is like, no, you give me the root, I'll build up the tree. And then maybe once the tree is built up, I will be like smart and I know how to just like re-render a portion of the tree. But at the very beginning, at least once, I have to render the whole tree.
Yeah. Right. Yeah. I mean, yeah, that's how they work.
And that's the problem, because at the very beginning, they have to render the whole tree. The game's lost. Like you just forced the download of the whole application.
Right.
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 And so what makes Qwik special is that it knows how to like do stuff in the middle of the tree. So let me show you an example for that. I'm going to skip over this reactivity example. Let's just go to clock. This is another one of my really favorite examples. So let's go to the clock. No JavaScript. Let me scroll the clock into position. You see the JavaScript showed up, and more importantly, the clock is moving.
And so that was when it came into view.
That's exactly. So let's do this again. No JavaScript. And when I scroll, the clock comes into view.
Nice.
You can see it. Now it's even cooler. Let me do it from the div perspective. So here is our two clocks. You can see that no dumb updates are happening here. Right? When I start scrolling, see now this updates, right? Here are the updates. Notice the other one is still asleep.
Oh yeah.
Scroll into position. Now the other one wakes up and it does its thing.
Neat. And that's kind of there's been so many applications I've worked on where that in particular was what was needed.
And that is what was needed. I'm going to argue that that is actually next to impossible to do in any existing framework.
Right.
This idea of like not processing a piece of DOM and then processing it only when it becomes visible and then lazy loading its code, right? Because like some systems are smart enough to be like, yeah, I'll let you not process this, but you have to download the code eagerly. Like this is like a whole new level of like, not even downloading the code, right?
Yeah. This is like me going to the library asking for a book and they give me the book versus saying you have to read all the books until you find and then you can read the book you're looking for.
Yeah.
That's super interesting. Yeah.
Now we kind of looked at, like, we had a click button in the previous example, right? So notice what's happening over here. We have on Q visible. In other words, we created a synthetic event
Okay.
that gets fired whenever a component comes into view. So it looks like somebody clicked on a component when it became visible, right?
Yes. So that's
actually.
Oh, sorry. Go ahead. Go ahead.
Let me show you a trick here. Let's change this to click. Okay. Now I'm going to scroll into view. You see the second one, I didn't change to click.
Yeah.
It woke up. The first one is not waking up because I changed the event. But now if I click on it, it wakes up.
That's great. That's so okay. So my feelings as I'm watching this, and full disclosure, I did a little bit of research on Qwik before this, but I didn't want to do too much because I wanted to get it straight from you. I feel like a lot of frameworks, I feel like where we've gotten to over the years, and I'm talking about from vanilla JS to jQuery to et cetera, we've gotten to this place where we're fighting the technologies of the internet. Like HTTP is a stateless medium. The browser has the DOM, which is already this large, complex data structure that's available to you. It's already integrated with all these events for the actual interactivity. It feels like we've been fighting that for so long, trying to turn the web into something that it isn't. This feels
That's exactly right.
This feels like you're accepting, not just accepting, but really embracing the technologies that are already there and saying, hey, I've got this great data structure that somebody else built for me that has all these great events, and I can just attach onto that. And Qwik almost becomes more like the way CSS works, where it's just attached to the DOM.
It is totally, you totally hit it on the head. The way existing frameworks work is like DOM is this nuisance that they try to keep you away from.
Yeah.
Right? They're like, yeah, eventually it's a DOM, but like pretend it doesn't exist. We'll eventually update it. Just like pretend it's not there.
Yeah.
Right? Whereas Qwik is like, no, come on, like browsers are DOM. Like let's just like embrace it and love it.
Right.
Yeah.
And I feel like we've had this kind of false premise of DOM update bad, when really it's not the fact that the DOM is updating that's bad. What's bad is how much we're asking to do at one time. Right.
Yes.
Whereas if you're spreading out these DOM updates intelligently, and you're spreading out these JavaScript downloads intelligently, then actually that's the way the internet's always worked. So it's actually just fine. That's great.
Yep. Now, let me show you how this thing is implemented.
Yes.
I think it's worth kind of seeing this.
We like under the hood around here.
Okay, so here we have two components. We have a clock component, and we have a clock app, and then we have a clock itself. So the clock app, basically, there's nothing interesting here other than like it creates a list of items so that you get the clock to be below the fold.
Gotcha.
Right. So it's a basic component that creates 40 items, does some text. Oh, by the way, it looks like there's a click button on this thing. Okay, so let me actually refresh this. If I click on this, oh yeah, look, there's a click, and then the test comes on.
Yeah, which we never saw because we didn't invoke the event, so it was never loaded. Yeah,
which exactly this piece of code doesn't load when you navigate down here. It only loads when you click on it. But anyway, so the kind of the thing to point out is that this component here, if you think about it as a human, right, you realize like this is an inert component. Like there's nothing you could do to the system to modify this component, right? And so this is but most frameworks don't know this, right? And so they'll force you to download the component and execute the component and do all this other stuff. Whereas Qwik can look at this and be like, there's nothing here. So like, I'm just not even going to bother downloading this. And I'll show you this in a second. And then we have two clocks. And the way we implement the clock is we say, well, we need to have some styles that are required for the clock. So that's what we do here. And again, notice the $sign, right? The $sign means lazy load this.
Right.
Right. And in the case of a clock getting pre-rendered on a server, we have to insert the styles. But when we wake up the clock on the client, we already know that we have the styles from the server. And so this never gets executed.
Oh, interesting.
Right?
Okay.
So because but you could imagine a different situation where the clock wasn't rendered on the client, and then the clock gets rendered, so it's a brand new clock. It wakes up and realizes, oh yeah, but I also need styles, and so Go gets the styles as well.
Good.
And so whether or not you download styles really matters. Like, well, were you just created on the client without anything there, or were you created on a server and then the server already gave you the styles? In which case, when you wake up on the client, you don't actually need the styles. The styles are already there.
So Qwik is saying, based on the context in which I am rendering, what do I actually need?
Exactly. So this just specifies that you need styles. We create a store, which these are the angles of the different hands, right? Then you do something, use client effect, which basically says, hey, I need you to run some code. And the code you're running is basically this update function that says, this is how you compute the second, minute, and hour angles, right? Then you execute the function and you set up an interval to do this every second, right? And then, if the clock is to be kind of removed from the UI, then there has to be a cleanup function that runs. And so you return a cleanup function to say like, oh yeah, but you're going to have to clear the interval when this thing finishes executing. And then here's your JSX, right, to kind of print the whole thing out.
Gotcha.
Okay, so let's go to the client. Let's refresh this again. No JavaScript, right? Let's scroll into position. So the first thing that the system downloaded is the use client effect, right? Because that makes sense, right? Because, this component, all the components in the system are inert. There's no JavaScript. And because this use client effect, this thing right here, has a on queue visible, this is the event that got fired. And so the thing to do is to wake up that particular thing.
Okay.
Now, how did we know to do queue visible? Well, so if you're in the world where hydration is a thing, right, where you boot up your system, so to speak, when you come across a client effect, the answer is very simple. Well, when do you run client effect? Well, when you wake up, right? So the answer is very simple. You run it on hydration. But like when you're in the Resumable world and there is no boot up process, then the question becomes like, well, where exactly do you want me to run this thing? And two obvious things pop into mind. One is, well, you do it exactly when the page loads. So like you simulate hydration, so to speak.
Right.
Or you can kind of go a step further and you're like, actually, I only need this stuff run when it's visible.
Right.
And so the default behavior of use client effect is that it only runs when the component becomes visible. That's just the default behavior.
Yeah.
Right? Because if you don't see a component, like the things you usually put inside a client effect are things like updating the UI, measuring distances, or like whatever, right? And if the component is not even visible, like why are you doing any of this stuff?
Right. And I assume you can opt out of doing that if you have some situation where you do. But yeah, totally. Like the most of the time, you're not going to use the component unless the component is on screen in some way, right? Or even if you're using a screen reader, you've still scrolled to the component, and then of course there's the difference. Again, going back where most people were using desktops, and now we're in the modern age of most people using tiny little screens. That just makes even more sense because you're not going to have so much UI on the screen at one time.
That's right. So use client effect takes an additional argument that you could pass in here, and then that specifies like when to wake it up. It's just the default is unvisible, and it's kind of the thing that you want to do anyways, like 99% of the time.
Yeah.
So notice what's happening here. You created the application the way you would create it in any other system, and yet the way it actually behaves is so different. And not only that, you get this property that like you are really just downloading the code that is needed. Now, let's actually go back to the network tab in here again. So the first thing that downloads is the thing that updates the angles of the hands. That makes sense, right? The next thing that downloads is the framework itself.
Necessary.
That's necessary. And the last thing that downloads is the JSX to re-render the clock.
Right, because we need to update the UI, so that makes sense.
Because yeah. But notice what didn't download. This guy. right? The system correctly identified that like that is inert, is not going to update anything. It's not going to change anything. So why am I going to download this thing?
Yeah, so that tells me that Qwik has an extreme degree of DOM awareness.
Yes.
Like you know where a component is in order to know that, in order to not have to re-render the whole tree.
That's right. So let's kind of zoom into it a little further. Let me refresh this again. What's actually happening is that there is this state we kind of talked about.
Mm-hmm.
And if you scroll to the bottom of the state, you'll see that it has something called subscriptions. And in here, we have two instances of them. And so it basically says, if you modify hour, minute, or the second property on object, whatever that object happens to be, you need to invalidate component 0 or component 1, right? And if you scroll up, you see that there's these IDs, component 0 and component 1, right?
So it's serialized into the HTML.
That's right. So what actually happens when we navigate, when I scroll and the first component wakes up, we go and modify this hour, minute, and second property, which then causes the invalidation of component 0, which is only this component because the second component is still below this fold, right?
Yep.
That then somehow allows the system to kind of recognize that it needs to download this piece of code here, which is clock component. It's the use client effect clock component. So this is the actual JSX, right? So this thing over here says go download that piece of code over there.
Okay, gotcha.
Now if you go through all of this stuff, what you're going to notice is that the clock app is not even in here.
Mm-hmm.
Right? It's not just that we serialize the state and we kind of threw away, we kind of just don't trigger it. We actually go a step further and actually look at it and be like, actually, the clock app is actually not even reachable from anything.
Mm-hmm.
Like if you start with click listeners as your roots, and then you start following like how does the data flow through the system, you realize there is no way you could possibly get to clock app. Every single path that exists in a system, none of them will lead you to clock app.
Mm-hmm.
And so you don't even bother serializing. Like the client doesn't even know clock app exists.
Wow. That's right. Because clock app in that case is really just a way of grouping components that actually do have interaction in a way. So you don't need to know about it technically. I'm saying this as if it's easy, but you don't need to you don't need to know about it, because what you need to know is what's actually happening, right? The reality of what's actually happening.
Right.
So so in a way, you're saying the other frameworks today are muddying the entire process because you need to kind of carry this baggage along for the ride, right?
That's right.
And Qwik is not going to do that.
That's right.
Awesome.
That is exactly right. And this is what makes Qwik different and special. And this is also what makes it hard to explain to people, because when people come to Qwik, they just look at the syntax and they're like, oh, it's the syntax I'm familiar with. Like, who cares? It's the same thing.
Right.
What they don't see is actually what happens underneath, right?
Yeah.
And that's the really magical bit.
And much like systems like Next.js, there is a big piece of this is the server component then. This is not just a front-end UI library.
That's right. So we have something called Qwik City, which is equivalent to like Next.js, right? So if Qwik is equivalent to React, Qwik City is equivalent to Next.js.
That's great. That's cool.
And I'll show you some more of the kind of magic on it later. But anyways, I want to show you this idea of serializing state. So here's a Hacker News, because everybody has to have a Hacker News demo.
Sure.
And what Hacker News had to do internally is had to go fetch data from the Heroku API, I think, in order to know what this data is. And then they would data bind the data into the system. And so now when you have to serialize the state, the naive thing would be to serialize all of the state, which means you would serialize the JSON that came back from Heroku.
Mm-hmm.
But notice if you go to the script tag, what happened here? There is nothing serialized. There's no objects, no subscriptions.
Okay.
Because the system kind of looked at this thing and said, I know you fetched all this data, but actually I don't see any way that a user could possibly interact with the app that would cause you to need to re-render any component and therefore need data to come with it.
Yeah.
And so I'm actually not even going to send you this data.
That's
right?
interesting. Gotcha. Okay.
And so it is just dead information here, and so it gets thrown away. Now, if I click on a particular component, story, now I have data. But if you look into it, what you're going to see is that it's mostly these bunch of open, true, like there's gazillions of them. That's because every single one of these things that you see here, and this one has a lot of them, open and close, right? So if I close this, it collapses it. And then if I open it, you see, you can interact with it. And so the state that we have is the state about, is this thing open or closed, not what is the text over here.
Right. Because state is about change. And if something's not going to change, why store it?
Exactly. So what you will see here inside of the serialized state is you're going to see that the individual components got serialized, but you're not going to find the actual text.
Yeah.
Because that is not mutable. You can't change that.
That makes sense. Now, all these things make sense, and I keep saying that as if it was easy again. Obviously, this is there is a lot of work going on behind the scenes to make these decisions, to make these I'm going to say good, like performant decisions. But me, the developer, I don't have to make any of these.
Yes, that's the beauty of it, right? So, like, if you were in a just so we don't always pick on React, let's say you are in a Svelte world, and Svelte has this thing called Svelte Kit, and if you built this app, the Svelte Kit will go and serialize the state of the system, and so the state would be like the actual data that came from the Heroku API for the actual text, and so what you would see is that the resulting code would actually contain the serialized state of the data. Of course, it still wouldn't contain the serialized state of the framework because, they can't do that. But like, it's unnecessary, right? Because that data is inert. Like, you can never, ever do that, right?
But these other systems aren't fine-grained enough.
They're not fine-grained enough. No. That is exactly it. And so every demo also has to have a to-do.
Of course.
So I'm just going to go to the network tab, and I want to show you is just pay attention to what actually is happening in a network tab as I go and interact with the application.
I'm watching.
Right? So I start typing code downloads. I hit enter, more code downloads. I click on something. I delete something. I clear complete it. As I interact with the page, I edit something. Every single interaction is like, well, now you need a little more code for your application, a little more code, right?
Yeah.
At this point, I probably downloaded the whole code base associated with the to-do. But, as a developer, I didn't have to think about any of this stuff. That's how the system works. Like,
that's very cool.
Now, if I go interact here, I start with header component, right? But if I go and I first click the clear button, then I start with the footer. If I go and I edit this thing, I start with whatever the editing happens to be. So the number of entries into the system is as many as there are listeners on a page.
Right. And the most popular paths through the system was the things that'll be downloaded the most often.
That's right. And so one of the problems that the existing frameworks have is that when they create a bundle, they create one bundle that has one entry point, which is your main method that bootstraps the system.
Oh, right. Like an old C program.
That's right. So here we have a different problem. Like, we're resumable, which means that we need to be able to resume anywhere in a system. And so we need to have lots and lots of different entry points into the system.
Yes. And that, not only do you have all these entry points, but you've serialized it to the point that I could essentially say, look at my state right here. I just clicked this thing. The state is now at this and that, and you could pass that along. So you have this resumability, you have this fine-grained pieces. So I'm going to geek out a little bit about the developer to user experience designer connection that I see here, because I've done a lot of work in user experience design as well. And one of the difficulties is always connecting the interests of the developers with the interests of the user experience. Whereas, it's always kind of like, oh, the UX person wants us to do this and this is hard, and it's always that fight. But a big piece of usability testing is to say, what are the paths through an application? What are the things that users are clicking on incorrectly? So now I see this and say, oh, you know what? Hey, Mr. Developer, because this button works this way, it's forcing people down that really expensive download path through the application. So if we fix this together, you're going to improve overall, like the server usage and your AWS bill and whatever it is that you're dealing with, because we're only loading what we need as we go. So I just wanted to geek out about that for a second, because that's super interesting that the entry points to the application, the code is matching up to the user experience, because that's the user experience is the entry points to the application. And that's, I'm just going to sit there with that for a bit, because that's really interesting.
Yeah, the thing that I'm trying to parlay to people is that Qwik is just fundamentally different. It's like nothing you've ever seen.
Yeah.
Okay. And that's the problem that we're kind of facing, is that people automatically assume like, oh, just another framework. Why does the world need just another framework? And to some degree, I kind of agree with that. Like, the world doesn't need just another framework that does the same exact thing in a different syntax, which is kind of what Angular versus React versus Svelte versus Vue is. Like, they all do the same thing in the same exact way. They just happen to have different syntax.
Yeah. And
I'm not saying syntax is not important.
No.
Syntax is important.
Yeah. And maybe some implementation detail differences where the battling of things.
But like fundamentally, they're the same thing. Right? Whereas Qwik is actually something completely different.
Yeah.
It is, on a fundamental level, a different approach to the problem. And this is why when we talk about a resumable and we talk about this idea that no matter the complexity of the application, it always performs the same exact way.
Yeah.
Okay. So let's we did a to-do app. Let's kind of do the architectural overview thing.
Great.
So this is a standard application, right? You server-side render HTML and send it to the client. And so the client renders it, and I'm showing it in gray, meaning that it's inert. You cannot interact with it, right? And so the next thing the browser needs to do is need to download the application JavaScript for your page. And finally, it has to execute the application. And as it's executing it, it's attaching listeners and making it blue, meaning that the listeners are attached, which means that this is now interactive.
Yep.
Okay. Now you come in and you're like, oh, but I can do lazy loading. And I'm going to show you why the answer is no, you cannot. So you server-side HTML. And so you start, you download it and you execute it. And now you get to the point where like, great, I am going to be smart and I'm going to lazy load these particular chunks. Well, guess what? When the system comes across a lazy loaded boundary, because the component is visible, it has no choice but to actually go back and lazy load these things, download them, and finish hydration. Right? So lazy loading is only useful in the existing systems. Lazy loading is only useful for components that are currently not in your render tree.
Right. That makes sense, because you don't need context in that case.
Right. For the components that are currently in your render tree, lazy loading is actually a distraction. Right. And people don't realize this, right? And when they say your application is too big, they're still like, just lazy load everything. And what they don't realize is actually it's not that easy, specifically because of this problem.
And would it be fair to say that the idea that, okay, you can only lazy load things outside your render tree essentially means you need to like guess the future in order to know what to lazy load, because you don't know what components you're going to need in certain circumstances?
The way I look at it is like, when a component is in your current render trees in the DOM, right? You have no choice to do but to lazy load it, because you don't know if there is a listener or not, and therefore you need to download it and execute it just to figure out actually there was no listener.
Right. Okay, that makes sense.
Okay, so then we have these island architectures popularized by Astro, and what they say is like, look, instead of hydrating everything at the beginning, which is kind of expensive, how about we just hydrate when I go and interact with the page? So if I interact with the menu, I only hydrate the menu. If I interact with maybe the component itself, I only, hydrate this bit over here. And it's definitely an improvement. But these islands are still relatively big. And inter-island communication becomes a problem because one of the things that frameworks solve is inter-component communication. And because you just turned your component into an island is really an application, now you have an inter-application communication problem that you need to solve in some way.
Yeah, right. And different islands could be of different complexities as well. So you're not sure how much you're really saving.
Right. So then here is Qwik. And the way Qwik works is when I go and I interact with a particular component like this one, then only that component gets resumed. Now, specifically notice what didn't happen. Neither the parents nor the children of the component had to get resumed either. So the component, the thing that is cool in the Qwik is that it can do so in isolation. Right? It can basically say, I just need to do this guy, nothing else.
So I'm going to say that one more time. Neither the parent nor the child components have to get loaded. That's surprising.
But that's what you need if you want to be able to do lazy loading.
Right.
Because if you're in a world where the parent and a child has to get loaded, then you are in the world of you have to just download everything that's currently in the DOM tree.
Yeah.
And so the only lazy loading you can have are for things that are currently not in the DOM tree.
Yeah. Super. And that's the degree of granularity then. It's
even more.
Oh, okay.
Because visually we think of a component as a box, but in practice that component has a bunch of listeners. It has like use client effects, watches, tracking, resources, and so on and so forth, right? We can lazy load every single thing of these separately. So in the simplest case, you have a component, so they have a JSX, and those component has listeners. And so listeners and the JSX can be lazy loaded independently already, right?
Yeah.
Because if you think about it, when you have something like a shopping cart, you are either updating the shopping cart, which means you need to re-render it, in which case you don't need the click listeners, or you're interacting with a shopping cart, which you need the click listeners, but not all of them, because you only interacted in one specific way.
Yep.
And it may or may not result in a state change that may or may not result in shopping cart actually having to be re-rendered.
So this to me, Miško, feels as big of a shift as the shift from downloading a video to streaming a video. Yeah. Right? Because you're essentially building a streamable application.
That's right. Yes. The application streams and as you're using the thing, except in the case of a video, the streaming is very linear.
Right.
Right? Like it's a predictable path in which I have to stream. Here, the streaming is kind of unpredictable because it depends how the user interacts with the application.
Right. Right. So it's user-guided streaming of the application.
Exactly. So here's the kind of the point to make. Let's say I interact with this button right here. When I click here, notice this other button woke up. Right? This is what I mean by inter-island communication, right? There are situations where you interacting with a particular component might actually wake up another component somewhere far away.
Like a shopping cart up in the corner.
Like a shopping cart. Like imagine this would be add to shopping cart button and this is the shopping cart, right?
Yeah.
So me clicking add to the shopping cart requires the shopping cart re-renders. And so the beauty of Qwik is that Qwik understands the relationships between the components without actually downloading the components eagerly.
So yeah, so you have what you need to know. I need this component and the related components without actually having the components.
That's right. I have the information, right? I understand that, or the Qwik understands that, like, oh, adding an item to a shopping cart requires the shopping cart to be re-rendered, but it does it in a lazy fashion, right? Like It doesn't like download shopping cart and then add shopping cart to just realize like, oh, now they're connected, right? No. It has no information, right? It just understands that mutating this causes a change over there. And so if I actually mutate, not theoretically, like actually somebody actually mutated the thing, then I have to go download that piece of code over there.
That's great. And again, the developer doesn't, or does the developer have to indicate these dependencies in any way?
No, this is just like the clock, you automatically to render. Just like, let's go back to the counter, right? When I increment this thing here, the system can track back and realize it's used over here. And so it knows that mutating this causes a re-rendering of this.
Yeah.
Right? That's the way it actually works underneath is that the store is a proxy. And this proxy notices that you read from it over here. So you did a read on a proxy when you were rendering the component. And therefore, it understands that if you go and mutate the value, because somebody read the value, you know whoever read the value now is invalidated as a result of you mutating that value.
Okay. So when you're saying proxy, just again for our watchers, you're talking about the JavaScript proxy object, right? In particular, which is essentially a way of saying, I'm going to use this object to update this other object. Okay, great. So because I'm using this object over here, you know that actually it's connected to this other object that also needs to update.
That's right.
Okay.
That is exactly right. Okay, so that was that demo. Okay, so now here's the thing that I think might have not been obvious. It may seem that I have actually just showed you a bunch of independent applications. Actually, I've shown you one single application. Let me show you. I'm going to put all of these demos into a single page. No JavaScript here, right? And refresh. No JavaScript. I'm going to start clicking on the button to change the count. Hello to do the console. There's this other example which I haven't done, which you call the debounce. Here is our to-do. We can delete. Here is our clock. Every single thing is actually running on the same page. But again, no JavaScript to start with. As you interact with the page, JavaScript shows up. Or as you pointed out, it streams just the necessary JavaScript to get the particular pit going.
That's fabulous. So I can compose components and it really doesn't matter because I'm only loading what I need.
It doesn't matter, right? So even though this looks like separate applications, it's actually a single app that does everything, because when you come over here, like the system just throws everything away because it correctly identifies that there's nothing you can do. And that's why you don't get JavaScript. Not because the app is inert, it's because that particular section of the app is inert.
That's very impressive. It's impressive that all of this works. I gotta say, that's a lot of behind the scenes work to remove the complexity from the developer in order to do that. But I also love that you've removed the complexity from a system standpoint, but you've revealed the serialization essentially in the HTML so that a developer can go in and go, oh, I forgot to change this so that it starts up automatically instead of when it comes into view, because look, there's my synthetic event sitting there, and I can use that. That's pretty cool.
So let me show you our homepage, and then we kind of and of course the homepage is done in Qwik itself.
Sure.
And I'm going to actually show you a couple of things in here. So first, the homepage is actually two separate pages. There is the page owned by us, and this is Builder.io CMS systems for like automatically editing the UI. And so one thing you're going to notice if you go here is that this HTML here has it's paused, right? It has, just like we talked about, like there's a state associated with it, etc. It's paused, and it has a specific version of Qwik that it's running, and a particular URL where all the JavaScript is being downloaded from.
Okay.
But if you go down a little lower, you realize there's this div that has also Qwik version. It's also paused. It has a URL, and it actually is running a different version of Qwik. These are actually two separate apps on a single page, acting as one, coming out of different URLs.
Now you're showing off.
Coming out of different URLs. So if I go in and interact this button, if I click this button to copy the clipboard, you now see that this was actually a bad example because it's it doesn't even download the framework, so it didn't even wake it up.
Oh,
It would be a more complicated example. This would say actually that it would be the container would be no longer paused; it would actually be resumed, and you would see the interaction with it. So totally separate, deep dive we could do about how this really fits well with micro-frontends and how you can actually render your page on multiple backend edge services and then assemble it together as a single response.
Wow.
Okay.
Right. So if I'm imagining like a company intranet that has multiple apps, that might be displayed on a page, and boy, if you break this little piece over here because you want to update to the new version of Qwik because you need this new feature, you might break everything. But now you're saying, well, actually, just this one app can be updated to the new version of Qwik, get it to work, and everything else can still work on the old version.
That's right. So I can change the UI over here or the behavior or whatever I want, roll back or roll forward the subsection of the app without affecting the rest of the application, even without even deploying the rest of the application.
Yeah, that's huge because, I mean, as much as we talk about the cost to the company and the developer of building an app, maintaining and just getting an app working on a new version of a framework or some dependency is huge. So being able to do that has a big ROI potentially. I can see that. Yeah. And could I just ask real quick a question then? Like, do you see, let me ask this question the right way. How do you see adoption going forward then with Qwik? What's your picture of the ecosystem?
Yeah, so very complicated question. I think people will need to first understand the problem space of like lazy loading. Oh, sorry, this time to interactivity, and I think they have to understand that this is something that they need to fight for. And I think that's the foot on the door. Once they though start using Qwik, they realize that it can be done for things like micro front-end services, and specifically it can solve personalization problem, which is a hard problem in e-commerce that is kind of unsolved. But with this, multiple apps kind of assembling it themselves together, you can do personalization. The reason you can do that is because the things that don't change, like your hero image or your, featured product section, right? They can be pre-cached in a CDN. You could pre-render, men's shoes versus women's shoes versus youth shoes and so on and so forth, right?
Yeah.
And then when the person navigates to it, you don't have to do server-side rendering of the whole thing. You just go like, oh yeah, I just need to show the men's shoes.
Yeah.
I'm going to grab this pre-rendered content, spit it out over here. I'm done.
Yeah.
Right. And then I need a menu system. Okay, great. I need a 15% off because this is a return customer. Great. Just grab the pre-rendered content representing 15% off, just plop it in there and you're done.
Yeah, that makes sense. So now you're kind of democratizing this whole process for everyone. So that's really interesting. Okay, I'm going to ask one last question because I'm just super curious.
Okay.
Do you also see this affecting how we debug applications, the interactivity between users and the development teams? Because if you're able to serialize everything, do you see some like super logging one day where I can just grab everything about what the user is doing in the app in a moment and pull it into my machine and then just click and keep going and see what happens?
Probably. Actually, there's a cool demo that I didn't show you where we can actually run an application in a tab and move it to a different tab, because this resumability trick that gets us from the server to the client, we can actually use it to get from the client to anywhere else. And so, yes, you could have an application running and be like, okay, I'm curious why it's broken. You could serialize it, grab the HTML, give it to a person doing the debugging, and be like, okay, continue exactly what this user sees and see what's broken, etc. So yeah, that's actually, I didn't even think about that angle, but that's a beautiful angle. Yeah.
Cool. Okay, I'm done.
Okay. But I have a few more things to show you before I disappear.
Okay.
First, people always ask, like, isn't it problem on a 3G network when you click on a button and now you have to go make a round trip to download JavaScript? Okay. And so that is solved actually very easily. the system generates a prefetching code. All the demos I've showed you so far is without prefetching because they were like developer mode. But in production mode, the system generates all these URLs. So if you go to the network tab, and if I go to the mobile device, and I click this button, that's because we are running with disabled cache. Let me refresh this again. If I click on this button right here, notice what it says. It all came from the prefetch cache. So this idea that like this is actually slow on a mobile device is not actually a problem. Now, at this point, people say like, well, you're just downloading all the code that the application already downloaded. And I say, no. Because we have trimmed the amount of code that had to be downloaded. We only downloaded the code necessary to interact with this menu and nothing else.
Right.
All these other components that are on a page that are static, we never downloaded their code. So the amount of code prefetched here is a tiny fraction of the overall application. One, let's say it's a horrible situation. We actually have to download all of the code, right? The worst case scenario. The worst case scenario is we download all the code. We're still better off than hydration, because the hydration not only has to download all the code, it has to execute all the code.
Right.
So our worst case scenario is still miles ahead of the best case scenario of the regular application.
Yeah. So I could see how this is a challenge to adoption, because we're so used to you have everything to show everything. Right? We're so used to that mindset to say, oh, look, you downloaded code. We're not, we, the developers over the years have gotten very accustomed to give me everything, and then now I'll go do work.
Yes.
So that's a mental model shift for sure.
Okay, let me show you this thing. I'm going to disable JavaScript here.
My favorite button.
Demo. Yeah, and so now we're going to navigate to different pages. So no JavaScript is running, and for the most part, the application is usable. You can kind of see what's going on because all this stuff is pre-rendered on a server. Now, if we do complicated things like examples, obviously you're just going to get the spinner and it will spin forever. Or if you go to the tutorial, like you'll get text. You can go through the tutorial to go to the, is the next one not working? Oh yeah, the next one. Oh yeah, it works. You can go through the tutorial, but obviously the tutorial doesn't load because we disabled the JavaScript. But notice what's actually happening. Like all of this code that is actually pre-rendered on the server is going to do wonders for your SEO.
Yeah.
Even for complicated things like a tutorial, which is like this hybrid mixture of static text and interactive page, we still deliver a useful thing to an SEO. So now if I wake up this thing and I say enable JavaScript and I refresh the page, notice this time through the JavaScript will actually come in and the editor loads and the application loads and then you have a demo, etc. Now, the other thing that wouldn't have worked in JavaScript is these menus, right? These menus are clearly JavaScript related menus. But then everything else just kind of works, which is kind of amazing.
Yeah, and that helps you target those scenarios more cleanly, right? Like I can say, okay, I'm going to design my app for SEO when JavaScript is off, and it's pretty clear how we might approach doing that.
Yeah, and the thing that people kind of confuse us on is they say, oh, so you do all the server-side of pre-rendering. Oh, you're just like a static generator site. In a way, that's true, but the difference is with static site generators, you can't bring the application to life and make it interactive and like do complex things in them, right?
Right.
Whereas we start our life in a SSR way, and then as you do interactivity, if I navigate to tutorial, which is like this super complicated application because it actually allows us to edit. I mean, this is a full-on editor loaded here. This is a kind of a unique thing that we start as if we are server-side generator or a static site generator, but then we transition into this interactive application that can do full-on things.
So, and I feel like we're coming full circle here because Qwik, I've heard referred to as HTML first, and that's really what this is, right?
It's HTML first. It's resumable. There's a lot of different ways we're talking about it. But on the end of the day, you really end up with, it's just a very fundamentally different approach. And things that are hard in other approaches, like for example, loading a clock on serialization when it becomes visible, right,
Yeah.
is like trivial in Qwik because, well, it's just what Qwik does out of the box.
Amazing. I sincerely hope that this is where we're going in the future.
I think this is where we're going. Like, I'm not saying Qwik is going to be the answer, but I definitely think the answer is resumability. Like, we cannot continue building these huge monstrosities of JavaScript bundles and expect somehow that it's going to be okay.
Yeah, it's not good, and we've kind of throttled the internet in a way up till now.
Yep.
So
Yep.
this is great. I think it's good for app dev, and I think it's good for yeah, it's just good. So I'm going to change that. Okay. So Miško, thank you so much for spending time with us here. This was super enjoyable. So Qwik is qwik.builder.io, right, for people to go check it out. Any other links or any other topics for people to think about?
You can check out PartyTown, which is the third-party answer to the JavaScript problem. And maybe in the future I could circle back and first of all, you could probably have Adam Bradley on to talk about PartyTown, but I would like to maybe circle back in the future and just give a demo of the builder itself.
Sure. Yeah, that'd be great. Yeah, that sounds fabulous. We would love to have you back. We're happy to have you now. So thank you for showing us Qwik. I'm going to put the links in the description of the video. And so this has been Miško Hevery. I'm Tony Alicea. And thank you again, Miško, and we'll hope to see you again on the channel.
Thanks for having me.
All right, thanks.
Bye.
Thanks for watching, and don't forget to subscribe. Also, keep an eye out for coupons to my full courses in the descriptions of my videos. Happy coding!